we were talking about this extreme group method for discriminability, right? I think that's where we left off. And I stopped by, it's always weird to go to any store, it's just like an odd experience. But I was like driving over here and I'm like, I'll stop by. There's a Bed Bath & Beyond is sort of on the way. So I wanted to get a clock. I think last time, if I don't look at my phone, which I try not to do because I'm recording or whatever, I have no idea what time it is. So I went and got a little clock so I can put it next to the monitor that I look at so I can know what time it is. Because a lot of times I'll just ramble on stuff, not realizing that I'm taking way too much time. So hopefully that'll help some. So we got here in this whole idea of like, this is based on this, not assumption, but this sort of idea that if an item can discriminate well against sort of high scores and low scores, and the high score, right, we're talking about identified two extreme groups. The extreme groups are based on not on the item, but this is based on the sort of test total, right? So this is based on if you sum up all the items and sort of get a total for the test itself, you then create sort of extreme groups. Oftentimes just by cutting the groups into thirds, you use the highest third and lowest third. And what that does, it tells you, like if you're talking about depression, on the particular scale, the group that's in the highest third, those are the ones that are scoring the highest on depression. At least according to the scale, they are the most extreme on the high end, or the group on the bottom is the least depressed. Now, of course, because you're cutting into thirds, it's relative, because maybe no one's even getting anywhere near to the highest number on the scale, but relative to each other, these are the highest and lowest. So you use the top third and bottom third, and the idea is that if I have a high score, right, so if my total score on a test is really high, then the likelihood of me answering any of the questions on the test is then pretty high, right? So, to get a high score, I had to answer multiple questions. So the higher my total is, the more likely I am to endorse any particular item. Or the lower my score is, the opposite's true, right? If I have a very low score, then the chance of me answering really any of the items is actually pretty low because I didn't answer very many of them. So the idea being that if I find an extreme group that's really high, there should be more of them. The items should be less difficult for them because they're high on whatever trait you're measuring. So that's why we talk about computing difficulty for the top group and computing difficulty for the bottom group, meaning that there should be a higher proportion of people responding to the top group, meaning that the item is easier for them. And you compute the difficulty for the bottom group, and because they're at the bottom, any item should be more difficult. They should be less likely to endorse the item, so they should have a lower proportion of responders from that group on any item. And if there's a big difference between the items that are the difficulty in the extreme high, extreme low groups, then that item has a higher discrimination or higher discriminability score. And so you can create this discriminability index. When we started talking about that last time, I feel like we sort of went through it kind of fast. So these items are part of a sort of social anxiety subscale. I don't even know if it's an official scale in the MMPI, but it's a content scale that people have identified as part of the MMPI. And the MMPI has like something like 370 questions or something like that. It's a ton of questions. So there's just multiple items that seem to go together that seem to identify people with social anxiety. So you got things like, I prefer to pass people I know, all the way down to, in school I found it very hard to talk in front of the class. Whenever possible, I avoid being in a crowd, right? So it's social anxiety with a little bit of maybe agoraphobia or something, like, some extreme cases of people really wanting to isolate themselves. But it all sort of goes along with this idea of social anxiety. So if we look at, again, there are a lot of respondents, right? So the top group, the top third, is nearly 30,000. The bottom third is nearly 30,000. So we're talking about, a total of probably 90,000 respondents in here, because the middle third is being left out, right? So we're looking at just a ton of MMPI respondents that have sort of gone through this. So if you look at this, of the total people, these people who scored high on this subscale. So they tend to endorse many of the items. Of those people, 56% of them endorse the first item. I prefer to pass by people I know. That's almost like social avoidance. It's even, again, going past the just basic anxiety. It's like you're actively trying to avoid people. Right, so of the total in that group, there was nearly half of them, a little more than half of them, that endorsed the item and said yes. Now, I mentioned this last time, but it was kind of quick and in passing. This idea of endorsement doesn't always mean that they're answering in the affirmative. It could be that in the endorsement of the item means that you're answering the item in the direction of social anxiety. So the second question, I'm a very sociable person. So if you said yes to that, that actually means you don't have, or that's sort of the opposite of what you would expect with someone with social anxiety. So here, if you said no, that's really endorsing the item in the direction of social anxiety. And they call this the sort of the key to the items, like how the item is keyed. So here 1 means social anxiety, but on the next item that 0 means social anxiety. So it's sort of keyed differently which one is in the direction of social anxiety, and it sort of gets to this idea of sort of reverse coding with items, where this very social person is sort of a reverse coded social anxiety item. So okay. People that again are high on social anxiety, 56% of them said that they would endorse that item, said yes to it. On the low end, people on the very low end of social anxiety, the lower third, only 6% or so of them responded endorsing that item. If you take the difference between them, there's about a 50% difference between the high and low. So that's that item's discriminability index. And it's sort of hard to know, is a 50% difference, does that mean it's really discriminating? It's sort of relative to one another, right? So which items are the most discriminating versus the least? You got items that, don't really discriminate much at all. There's very little difference. So this item can't really tell the high and low social anxiety folks apart. Or the highest item here can tell them apart quite a lot. It's almost 80%, an almost 80% endorsement difference between at parties I'm more likely to sit by myself, or I forget what the rest of it is. Something like sit by myself or avoid other people or something like that at the party. Or I think it's either likely to sit by myself or with just a few people. Sort of limiting your social interactions at parties. So, I mean, this is a fairly, it's not the easiest process, because you got to do all these steps to break them up into high and low discriminating groups, or high and low difficulty groups or endorsement groups, and then sort of to start looking at the differences in difficulty across the two groups to get an index. But when you get there, it actually does a pretty good job of telling you which items seem to be doing the best at discriminating against or between the high and low social anxiety responders. So this is done as a way of looking at this sort of extreme group method. It's done as a way of looking at discrimination, but it's not the most typical way, because there's easier ways of sort of looking at this. So one of the probably more common ways is to look at something called the item total correlation. So the idea here is that if I let the total test score, like the sum total on the CESD or something, represent the trait of interest. So, all right, the total test score is their level of depression on the CESD, or the total test score on our MMPI sort of content scale is their level of social anxiety. Higher numbers mean higher social anxiety, lower numbers mean lower social anxiety, okay? So let that sort of stand in for it. What we can do is, we're going to talk about factor analysis next, where factors are these sort of latent variable versions of what we're talking about here, but we're basically having these the total test score sort of stand in for the actual trait. That is their depression level. So if I want to know how well an item discriminates, tells the difference between high and low responders, I can simply correlate that item with the total. The higher the correlation is between the item and the total, the more discriminating the item is. And again, the idea is it's a better reflection of the total, therefore it's more discriminating. And another way of saying that is, if people are to vary on the item, right? You got people who endorse it versus don't endorse it, right? If that variability corresponds with the variability in the total, so people that are higher tend to say yes, people that are lower tend to say no, it's going to have a high correlation between the item and the total, giving us then a fairly good indication of how discriminating that item is. So we're going to correlate each item with a total test score. Items with a higher item total correlations are more discriminating. And these correlations will act like a rough estimate, a proxy for factor loadings that we'll talk about next. So the issue here often, because if we're talking about dichotomous items, like items that are scored either correct or incorrect, or yes, no, or like the MMPI items that are just either you agree or don't agree. If you have a dichotomously scored item, or items with have a correct answer, if you correlate the dichotomy with the continuous total, you really are leaving the realm of a typical Pearson product moment correlation, because Pearson correlations are designed to correlate two continuous items. So instead, you have one dichotomous and correlated with one continuous. That kind of correlation is called a point biserial correlation. The way that you compute the correlation is not that different, but the way you interpret it is a little different. Because the dichotomous item doesn't have a lot of variability, it just varies from 0 to 1, its ability to correlate or to share variation with another item is more limited. So what it does is it changes the way we interpret the correlations, where relative to a Pearson product moment correlation, smaller point biserial correlations can be seen as significant relative to their Pearson counterparts. So it changes how we decide on what is a significant or not significant correlation, simply because we know that it has more limitations on how high it can go. So we oftentimes will correlate the item with the totals using this sort of point biserial correlation method. And realistically, most people just use Pearson, but they'll be a little bit more relaxed about how large the correlation needs to be before they consider it a large or discriminating item. So to give you an idea, these are the same items, and I did an item total correlation between each item and the total. Okay, so what do you notice here? Which item seems to be the most discriminating? Exactly, it's the same item. So this method is capturing the same information. It's telling me that this is the most discriminating item. And then if I go down to, I think it's this one, I'm never happier than when alone, that item is no longer, though, the least discriminating item. Right, so this one was, I think if I remember correctly, it was that item that was the most discriminating before. I'm sorry, the least discriminating before, the 0.219, right, is now this 0.326, but there are items like this one that are actually lower now. My worries seem to disappear when I get into a crowd. All right, so the information you get from the point biserial or item total correlation, it will be similar to the information you get from doing the extreme group method, but they're not necessarily going to be exactly the same. This is a much simpler method, and in programs, especially I'm thinking of SPSS, when you go to do like a Chromebox alpha, you put items in and you ask for a Chromebox alpha, you can add in as a little checkbox you can get that'll give you the item total correlations like this, so that you can actually look at which items seem to be doing a good job versus a poor job of discriminating between items. As a way of looking at where, because the Chromebox Alpha is looking at all the items as a whole test to see how well they sort of go together. Well, if your Chromebox Alpha ends up being sort of lower than you'd like it to be, one thing you can do is come here and look at, well, which items seem to be functioning poorly or doing a bad job, and getting rid of those items can actually make the Chromebox Alpha go up. Because Chromebox Alpha is based on this idea of summing the variances and covariances of items, if if an item has a poor correlation with the total, it likely has poor covariance with other items on the scale, and that's why it's actually driving the Chromebox alpha down. And so I should mention, and again, it's more or less thinking about this relatively. Notice I didn't include significance or other things, just thinking about on this scale, the item that seems to be the most discriminating. So like if I were to use this one item, at parties I'm more likely to sit by myself, etc. If someone said yes to it, that's a pretty good indication that they are likely in the higher group. If they say no to it, they're likely in the lower group. Same thing here. This again, this is a reverse coded item. I'm a very social person, so you got to think about it's really I'm a very unsocial person or something like that, antisocial person. This item is actually fairly discriminating too. If someone says no to this, they're likely in the extreme social anxiety group. If they say yes to it, they're likely not. So it tells us a lot about the items like this, right? If you're someone who has social anxiety, you're not going to say that you like parties and socials, right? So if you say no to this, you're likely in the extreme group. If you say yes, you're likely in the low group. Okay, so it tells us a lot about sort of which items seem to be correlating or predicting a person's sort of overall trait well. So like the idea here is that if you were going to pick just one item to ask, right, you'd want to pick one of the items that are most discriminating to tell you whether or not they can tell the difference between the high and low responders on the overall test. So we talked a little bit about the z-score thing before with difficulty, and I think somebody asked me like, why do we do that? And there was something I forgot. So if oftentimes we want to use the information about the difficulty of the item and the discrimination of the item together. We want to be able to look at them at the same time and make a decision about which items seem to be good. Remember I said that there's a couple pieces of information we use to decide if an item is usable or not. If we want to retain an item on a scale, one is the difficulty of the item, and the other one is the discriminability. So what that allows us to do is to put the difficulty, if I convert it over to a Z, and I take the discrimination and I convert it over to a Z, it allows us to put the difficulty and discrimination on the same sort of Z-score scale, so we can see where the combination of the two things sort of fall. And I'll show you a picture of that in a second. So that was one of the things that when you asked me the question before, I totally forgot that oftentimes because we want to be able to look at them together, and sometimes it's hard to judge the difficulty and discrimination of items sort of in a way that's not just relative to each other. So if we can put it on a similar z-score scale, we can then make decisions about the quality of the items on those two combined sort of measures. So if we want to be able to take the item total correlation, we can actually plug that number in. We can then transform it using the same sort of log, natural log function here, and put it into a format that is, sort of a z-score method. Now, because they're correlations, you're not going to have any negatives, so it's going to be on a scale that's more or less positive, going from sort of 0 to infinity, presumably. But if your correlation is real small, 0.10 ends up being the same. And as you go farther away from 0, the numbers get expanded a little bit more, because you're actually taking a curvilinear function and stretching it out to become linear. So as you go farther up towards 1, the difference between the correlation and Z become larger, and we can actually use these numbers along with the difficulty, the converted difficulties, to actually look at what, is there some combination of difficulty and discrimination that we'd like to keep, so we can identify items that stay on the scale and get rid of ones that don't seem to be working very well, either because they're too easy or too hard, or because they're not very discriminating or something. And all I did here is I took 0.10, plugged it into this equation, and I got back 0.10. 0.25, plug it in. Right, so I put 0.9 into this equation, I get 1.472. All right, so we can look at all these items that we talked about before. where it does, what it does tend to do is sometimes you'll have the discriminations all don't look that great relatively, but this tends to exaggerate the ones that are more extreme. The 0.622 becomes larger. It actually pulls it out farther. The 0.623 becomes 0.73. So it tends to sort of accentuate the larger item total correlations, so it becomes easier to figure out which ones are highly discriminating and which ones aren't. Not that that's really necessarily the goal of that, but it does help sort of accentuate the differences where smaller correlations are change very little. Larger correlations become even more large using the transformation. But the main thing is that we want to be able to look at them together. So I don't actually have this as discrimination and probability, but you could have this be the z-score for discrimination, the z-score for difficulty, and it would be something similar because it wouldn't, the scale wouldn't be sort of squished. But you then figure out which items fall between an ideal difficulty, so they're not too difficult, not too easy, they're sort of in the middle, in the range a little bit. And then you also want items that are discriminating enough. This is keeping a fairly low range here at 0.3, but you want items that are sort of at least discriminating enough and in the right range of difficulty, and anything that's in that sort of gray box are then items that you would use or keep or whatever it is the point of the process is. You would actually want to use those items and either maybe restructure these items or get rid of them or something, so that because they're sort of failing on one of the two categories. Either they're not discriminating enough or they're too difficult or too easy. In reality, what you really want for items is a variety of difficulty. So I mean, this almost seems a little bit too narrow. You want to have some easy items. You want to have some, medium difficulty, and even some difficult items in your scale. You want there to be some variety, but you do want them to be discriminating. You want them to be on the higher end here, so they actually can tell the difference between people. Or else the item is not super useful. It's not really telling you a lot. It's not giving you a lot of information about the respondents if it's not very discriminating. So, okay, so these are sort of mathematical approaches. Let's look at the difficulty by looking at the proportions of respondents that are endorsing an item. And by the way, I've only really mentioned difficulty and discrimination when it comes to dichotomous items, where the higher proportion of respondents that endorse it mean the item is easier, the lower the endorsement. But what about items that aren't measured that way? I don't really even have this in here, I don't think. But items that are measured, say, on a Likert scale, you could still compute the means for the items. And if it's, let's say it's a 7-point Likert scale, if the mean's around 3, people are essentially neutral. If the means are lower than that, then it's sort of a difficult item to agree with. If the means are above 3, then it's an easier item to agree with. And you can sort of get an idea of what the difficulty of an item would look like if it's not necessarily just proportion of endorsement. It's just going to be on the scale that the question is asked on. If it's a 7-point scale, it's going to be out of 7 points. And you got to really look at what the anchors are for the question to be able to figure out if it's an easy or difficult question and where to sort of make the cutoffs. So it still applies to sort of social science type items, not necessarily just aptitude or, correct, incorrect, dichotomous items. It just changes the way you look at them a little bit. The same basic idea. So what about a more sort of graphic way of looking at the quality of items? So we talked about computing means to look at the difficulties. We talked about computing correlations between items and the totals. We talked about the extreme group method. Let's look at just the way that items function and how the patterns of responses can tell us a lot about how an item is, or how good or bad an item is. So one way to do this, and this is really not the way that I'm sort of going to show you, is not like the official way that this is done. Usually it's done on a much more fine-tuned way to figure out exactly where all the proportions or probabilities are along the route. This is just sort of a simple proxy for it by creating what I call these total score groups. And what we really should be doing, that's a more difficult way of doing it, is one, looking at it in a much more fine-grained way, but also instead of using total groups, we should be using, often that's what's called a rest score group, which is a really weird term, but it's sort of funny when you think about it. Rest score. So the reason why this comes up, if I take the correlation between item number 1 and the total. Okay. The problem there is that item number 1 is partially making up the total, right? So item number 1 is in the total. So if I'm correlating item number 1 with the total, part of what's driving that correlation is that item 1 exists inside the total score. So there's some redundancy there. Where a rest score would be correlating item number 1 with the rest of the items. So it's still a total in a sense, it's still summing up, but it's summing up all other items that isn't 1, right? So it's the rest of them. So literally someone called this a rest score because it's literally the sum of the rest of them. Okay? So let's say I had a 5-item scale, right? I would say I would take the correlation between item number 1 and the sum of items, 2, 3, 4, and 5. And this would be the rest score relative to item number 1, right? Because item number 1 correlated with the sum of the rest of the items. I drew that kind of high. Well, let's look at another one down here. So let's say for item number 2 now, I want to correlate item number 2 with the rest score. I'm going to correlate item number 2 with a slightly different score. I'm not going to sum up items 1, 3, 4, and 5. And this is the rest score for item number 2. All right? So every item is now being correlated with a slightly different total, different rest score, but that helps to sort of reduce the inflation of the correlation simply by correlating an item with a thing that includes, correlating an item with a thing that includes the item, which is going to make it seem artificially higher than it probably would be. I don't worry too much about this, only because we typically are looking at the discriminability and stuff of items sort of relative to one another. So if they all have this extra little boost in it, then looking at which items are more discriminating versus others probably doesn't matter that it's the correlation between the item and the total. But a lot of times in literature and things, you'll see people actually do these, and the item characteristic curves. I'm going to use, just for simplicity, the total score groups. But in a lot of places in literature, they will instead, in the same idea, instead of using total score, they're going to use rest score groups, which means that every group is recomputed for every item because every item is going to have a different rest score. I didn't want to complicate things that much. So if you look at, on your the homework number 4, when it talks about I just took the total score, split them up into multiple groups with increasing amount of endorsement, like higher scores, higher total scores, and use that to create those sort of ICCs. But those ICCs, you can tell they're a little bit crude. They're not like nice smooth curves. They're sort of a little bit jerky because it's using just, I think, 5 or 6 groups as opposed to something like 18 groups or something that's a lot more fine-tuned that you'll see in a lot of other ICCs. So these are just sort of simple ways of looking at ICCs without getting overly complicated. So if you look up something, you find that using rest scores, that's what a rest score is. The first time I heard that was funny that they needed a rest score. So what do these item characteristic curves do for us? It's a nice way of illustrating what this stuff would look like. So good items, so here I only have 1, 2, 3, 4, 5, 6 total score groups. So these aren't rest scores, so it does have that issue that the item we're looking at is actually built into this, but it still gives us pretty good approximation. So you see this says good item, and it says next to it monotonic. Does anybody know what monotonic means? Or what monotonicity is? You can think of it as, you got mono, which is 1. I'm not sure what the root of tonic is for this particular use, but think of this as sort of a good item is sort of, it goes in one direction, one way, or something like that. So you notice that as we go up in total scores, so whatever this is, this test has 24 items or something like that, because you're able to get a score of 24. So you got people down here in the lowest group that endorse very few items. They have 0 to 4 as their total. Then you got people who are slightly higher, 5 to 8, 9 to 12, 13 to 16. So on and so forth, it's going up. These groups are not always of equal range because it's grouping them based on the number of people, not the range of scores. So it's trying to find 6 evenly split groups to put into, to create these total score groups. We can look at this. So what monotonic is talking about, and this is actually, it's a fancy term for this idea that whatever this item is, as people go up in their total score, each group, this represents a group of people, the percentage of people endorsing the item should go up as the totals go up. Meaning it should go, it's increasing from here to here. It continues to increase. Each new total score group has more people, a larger proportion of people endorsing this item as you go up. So think of that as an example. Again, pick on depression. So if these are the totals on the CESD, or the Beck Depression Inventory or whatever. So you got people who are super low in depression. They answered yes to very few items. You got people who answered more, and so on and so forth. So they got higher total scores. And you pick on an item like whatever. So I sometimes feel sad. Just whatever the item is you like to pick for depression. So I sometimes feel sad. People that answered very few items are going to have a low probability. There's going to be a low percentage, a low proportion of them actually answering yes to that question. But as the score goes up, more people in this group are going to say yes to I sometimes feel blue. Even a large proportion. So as the score goes up, more and more people in each of those groups should be endorsing the item. If that's true, as this goes up, the proportions of people responding to it continue to also go up. That means the item is monotonic. It is increasing or decreasing in a single direction. It doesn't change directions or anything. It goes ever sort of upward as the total score groups go up. That's a monotonic item. So to illustrate that, this is a non-monotonic item. So something's a little weird here where, again, whatever this item is, as people are more, answering more and more of the questions or endorsing more of the questions or getting more of the questions correct, this indicates that these people have, are higher on the traits or whatever it is. So let's say it's math ability, right? So down here, people who took a 24-item test and got none of them correct, they don't have a whole lot of math ability. Not very many of them are going to get this item correct, right? Probably none. But as you go up in math ability a little bit, right? So now you've answered 5 to 8 of the questions correctly on a math test. Well, the chance that this particular item has a higher proportion, more of you are going to answer correct. As you answer more of the other questions correct, your likelihood of answering this question correct goes up. You get to a certain point where you've answered enough questions where the proportion of people becomes very high that most of them now have, because they have a 13 to 16, they have a higher math ability overall, which means the likelihood to answer this question is higher. A higher proportion of people are going to be in there. It continues to increase. So now I have even more math ability, and so more people in this math ability group, math total group, are going to answer this question. But all of a sudden, the people in the highest group with the most math ability otherwise are less likely. Less of them are getting this question correct. That seems odd. It represents some kind of non-monotonicity. It's a non-monotonic item. It's actually starting to, it changes direction. And you can sort of see sometimes this happens. I'll give you an example where you can have a certain question that may be actually a fairly straightforward, fairly easy question that, if you don't know that much about an item if you know something about the topic, you may actually get it correctly. But when you know a lot about the topic, a lot about the thing, you may actually know enough to know that the answer is the answer that's supposed to be correct actually is incorrect. I've seen this happen a bunch, where giving a test to, say, a junior level stats course about that material, knowing full well, and this is like this with every class you take that sort of has prerequisites. You take a class and like, hey, this is how things are, and then you take the next class and they're like, yeah, I know in the last class they told you that's how things were, but this is really how they are, and you sort of learn more details and it gets more complicated. And then the next class is like, yeah, even that's not really true. This is what really is going on. And so things get more complicated as you go forward. So sometimes you have a student who is very advanced that knows those sort of complications will actually get a fairly straightforward question incorrect because the reality is the answer is more complicated than the test question actually makes it out to be. So this is possible to have someone who with a really high level of math or math ability, actually a bunch of them get it wrong because at some point they have enough math ability to know that the question is misleading or is missing some information. Anyway, not to get too much into that, but we are assuming that items should sort of flow in one direction if they work well, if it's testing the trait. Remember, the whole point of this is we want to be able to test math ability, if that's what we're testing, or depression. So I want to know how well this item relates to depression. And if all of a sudden people with really high depression have less likelihood than people with lower depression than them, all of a sudden the item becomes very, it's not very useful. It doesn't do what we want. We want people who have higher scores to represent more depression, and yet an item measuring depression has less likelihood in people in the highest score. The item is not working in the way that we want or the way that we intend. Okay, so we got monotonic, non-monotonic. So we want items to be monotonic, to sort of increase in one direction or to decrease in one direction. That's fine too. But it shouldn't sort of reverse on itself like that in terms of the proportion of people endorsing an item, or else it makes the item sort of tricky at best to sort of use. There's another item that's sort of non-monotonic. This one's all over the place. This one makes no sense. It looks like first it looks sort of monotonic. You're going from a low proportion here. It goes up again. Then it goes back down. You get to about the middle of the trait range in the total test score groups. All of a sudden it switches direction, and now you're back to almost the same portion you were when you were looking at people who had 0 correct. And it goes up and continues to go back down again. This is, again, in terms of looking at discrimination and stuff like that, this is not a very good item in terms of reflecting the total score that you're trying to look at. Right, so in terms of this item, so the question is, if you're looking at a single item relative to the total, and it's all over the place like this, does that mean that it doesn't really tell you a lot about the total? That's right. It's saying that this item doesn't seem to be doing a good job of reflecting the discrimination and even the difficulty we'll talk about in a second of the item the item isn't doing a very good job of reflecting the overall trait that we're trying to measure. So if the total score groups here are based on your total depression inventory score, well, this item doesn't do a very good job of sort of capturing that total, which means this item may not be that related to depression in the first place. So yeah, so that's a good question. Like, is this item really just maybe tapping two different constructs and it's being picked up on the lower end by folks who don't know it very well? And it's the same sort of story we talked about here, just worse. It's a more pronounced difference, where you had to get to people who are super knowledgeable and got everything else correct to get this one wrong, because they know something that these other students don't, that actually makes their answers likely, or makes endorsing the items actually not quite right. I've had students who have argued about certain test questions where they're like, yeah, but what about this? And it's something we hadn't talked about. It wasn't in class. It was based on something they learned somewhere else. I'm like, oh yeah, that's totally true. But at this level, we're not really considering that. They're like, well, it's not fair. And I'm like, so I'm giving them points back, even though technically they answered the question wrong on a multiple choice test, but their logic was correct, that knowing more about it actually led them to the wrong answer, the wrong based on the test, but it actually was the right answer based on the content. So it gets complicated. But that could happen here. This looks like that division, that split may happen somewhere between here and here, where if you're of medium knowledge about a thing, right? This is again math ability, and you're sort of going up. You're here, but once you go past that, there's something that you learn in between here that actually makes you consider not endorsing an item, and becomes less likely that you would do so because you have higher knowledge. That's one way of explaining. I mean, that's to me the easiest way to think about why that would happen. It also could be a different story we'll talk about later on, where you will see these kind of item characteristic curves in Criterion reference tests, where you have sort of mastery learning, where students are allowed to take quizzes multiple times to increase their score. Then you will see these kinds of curves like this, and the items don't necessarily have to follow a monotonic pattern, because you're getting different responses because of the mastery learning. So we'll come back to that at the end of this. But for now, let's think it's just we're expecting that more endorsement, more items answered means more of a trait. So each item, as you look at the total test score groups, you should get more endorsement as you go up in group. More people should be answering that question correctly. That's what we're assuming is going on with the items. All right, so these are the same items that we were looking at before, all the same ones, but looking at them in terms of, instead of looking at just difficulty and discrimination, we're looking at the item characteristic curves. So one thing to keep in mind with a lot of these is that right here at 50% is an important sort of piece. That when you take this down here to wherever this is, and then drop this down here, it gives you a pretty good idea in terms of difficulty. So how much knowledge, whatever this is, let's say again it's math ability, how much about this particular math topic do I need to know? How high does my math ability have to be before I get to a point where I pass a 50% likelihood of getting this question correct? With social science stuff, it's the same idea, but it's a little different. In this case, it's social anxiety. How much social anxiety do I need to have? What level of social anxiety do I need to have before I would answer yes to this question? At least have a 50% chance. So down here, I have a less than 50% chance. So all these groups have a less than 50% chance. I get to here, and then I pass by this 50% chance, which tells me that somewhere in here is when I'm going to switch from not endorsing to endorsing the item. I have to have a sort of slightly higher than sort of middle amount of knowledge about it to be in one of these higher groups before I would even have a 50% chance of responding yes to this question. So think about it. I prefer to pass by people. Remember, before it was cut off, so this is the whole question. Before I prefer to pass by people I know but have not seen for a long time unless they speak to me first. Okay. So as a measure of social anxiety, okay, in order to say yes to this item, I actually have to be, if you think of this as being the middle, right? These are the lower social anxiety folks. These are the higher social anxiety folks. I'd have to be sort of at least higher than mid level social anxiety. I got to be in one of these groups before I'd even have a 50-50 chance of saying yes to this item. And I got to go to one of these higher groups before I get to a 70 or a 92% chance. And we got no groups that are at 100%. Nothing. It doesn't ever reach that point. All right. So this tells you a couple things. How steep this curve is going up like this. If it's this is relatively sort of a slow slope to the curve. The flatter that it is like this, the less discriminating the item is. The steeper the curve gets, if it starts to go, see if I get my hand in the right place here. If it starts to go like, more steep, where you have a curve that looks more like an S, then those items are more discriminating. So where the 50% mark sort of lands tells you a little bit about the difficulty. If it's over here, it's an easy item. If it's over here, it's a very difficult item. Right? So the higher that point, that 50% mark goes, the more difficult the item is. The steepness of the curve tells you sort of how discriminating is. The more discriminating, the more sort of steep this change should be right around the point of the 50% mark. Let's look at, so you'll see more of that as we go through this. If you remember, 43 wasn't a very discriminating item. Go back to the list. All right, 43 has a 0.49. When we do it under the extreme group method, it was a 0.50, right? But the second question, I'm a very social person, was a pretty discriminating item. It's 0.729. So let's look at the difference in their curves between the first two items. So item number one, it's kind of a slow, gradual change, especially right around the 50% mark. Item number two, again, has a much more sort of steep. It's not awesome, but it has a much more steep sort of change right around that 50% mark. It looks like it went up just a tad, so it's not quite on 50. But where it passes the 50% mark, so what do I know about this? Looking at the curve, the 50% mark again being here. If I look at this, where this falls is now here. So I know that this item is more discriminating because it has a steeper curve, but I also know it's slightly easier because I had to be in a higher group before I got the 50% in the last question. If you look back at that. All right, I had to be here before I got the 50%. Now I'm getting 50% in a lower group, which means it's a slightly easier item. More discriminating than 43, but a little bit easier. The difficulty is a little bit lower. It's usually the steepness, because when you look at these like probability curves, they oftentimes, if we were to do this like as a numerical integration, where we're looking at every conceivable continuum of these scores down here instead of looking at groups, they tend to look like this. They have these sort of S-shaped curves. And so down towards the bottom and towards the top, you get very little change at all. So most of the change happens in the middle, and that's typically because of how this is measured. Typically right around the 50% is where you're going to get the biggest change. This is where it is the most discriminating. So you can figure out, well, okay, if it's most discriminating here, but I have another item. Let's see, I'll do 3 items. What we can tell about these 3 items is the green one, they're all about equally discriminating because the slopes are about the same. But the green one is easier. The pink one is the most difficult because I have to have more of the trait to get to the same probability of answering the question in the affirmative or getting the answer correct. So again, think about this as math ability. This is math here, right? All right. In order to answer this question correct, I can do so with less math ability. I don't have to have as much math ability to get this question correct because it's easier. For the pink one, I got to have a lot more math ability to to have the same probability of answering it correct. So that makes it a much more difficult item. So yeah, we are talking about the steepness generally right around wherever it hits the 50% mark is where it is likely the most discriminating, and that'll tell you a bit about how difficult the item is too. All right, I like to go to parties and other affairs where there's lots of loud fun. It's not very discriminating, and is it easy, difficult? It's super easy, right? There are people down here at the 50% mark, in between sort of the 2 lowest groups. What else do you notice about the fact that there's this too? You can think of this gap here in a couple different ways. One, because this is a psychological, social science type thing where yes, they're answering yes or no, but it means that you can think of the item is so easy that it never actually reaches 0. That even people in the lowest score, like this may be, think about it, for some of these people, this may be the only question they answered yes to, right? Because they only answered 0 to 4. So if they're a 0, they couldn't have answered this question. So if they answered 1 question in the affirmative and their total score is 1, this is likely that item. Because there's a 35 or so % chance, 35% of this group answered this item yes, even when they answered very few other items. If this were something like an aptitude test or a test of ability or something like that, this may represent a different thing. This may, because what happens when you have, let's say, it's a multiple choice test or something like that, and you're testing math ability or math aptitude or something like that. What you may notice is that with like a 5-choice multiple choice test, that this point at the very lowest, people with no math ability, they know nothing about this topic, will still have a 20%. They'll be like here somewhere. You still have this. It'll never actually get to 0. Why? Because this could, for those kinds of tests, this could represent something like guessing. That even if you have someone with no ability, if they're taking a multiple choice test where it's either correct or incorrect, they may have a 0.2 or 20% chance of getting the item correct just by accident if they guess. So that gap sometimes will represent guessing. Here, it just, I think, represents the fact that the item is just so easy that the line never really goes down to 0. Yeah. All right, moving on. We got to get moving forward here. I ran out of time real fast. So here we go. Another item, sort of. This item looks almost exactly the same. I would expect these to have very similar discriminations, very similar difficulties. All right, so it makes me uncomfortable to put on a stunt at a party, even when others are doing the same sort of things. I'm not sure what the stunt is they're talking about, but whatever it is, it has a certain level. So back up a second, what this actually means. Go back to here. I like to go to parties and other affairs where there's lots of loud fun. So one thing to keep in mind is that this item is reversed. So this might be a little bit confusing. Remember, in terms of social anxiety, this is likely scored the other way around. It's likely scored, so it's really I don't like. Right? Because this, if you like to go to parties and other affairs where there's lots of loud fun, you don't have social anxiety, or at least not a debilitating level of social anxiety. So this item really is I don't like it. So what that means is even for people who don't have social anxiety, there's some who still like, I don't like going to parties. And so there's a part of this item that's not related to social anxiety. There are people with no social anxiety that still don't like to go to parties and other things. So this is actually a reversed item. This one's a little bit clearer about that. It makes me uncomfortable to put on a stunt at a party. So this is a forward worded item that if you say yes to this, that's supposed to indicate social anxiety. But even with people with low social anxiety, there's a good 32% of them are still like, no, I don't like doing that. So I don't have social anxiety in any other way, but I don't like doing, it does make me uncomfortable to do things like that at a party, even when I don't have social anxiety. Right? So there's still a certain level of endorsement for low people, even when they have little to no social anxiety. All right. Moving forward. Here's actually a pretty nice looking item. I find it hard to make talk. That can't be the right wording. Whenever I look at this, I'm like, I must have copied it over wrong or somebody wrote it in wrong. But I think it's supposed to be, I find it hard to make small talk. But I've not verified that. So let's assume that's what it is. That sounds a lot better. Because to make talk, I like to make talk. I don't know. It's just a very strange way to say it. So I find it hard to make small talk when I meet new people. People with little to no social anxiety are way down here close to 0. Right? You're getting about 5% of them. And it's going up nice and smooth. It's not super steep, so it's not the most discriminating item, but it actually has it's a fairly nice curve. It's going up, and it's actually, the difficulty is somewhere right around this group here. So it tells me that, the big change is right around this group going. So you can really sort of discriminate between people right around these scores. You get the most information telling people right around this range apart, because that's where the most difference becomes. where you get the most change in percentage. All right. I wish I were not so shy. So look up here, you get a similar issue with the problem too. That even if you're in the maximum group, I have the most social anxiety, you're still not 100% likely to sort of endorse the item. You don't never really gets anywhere near 100%. So part of this question is a little bit tricky because there are people who have social anxiety and wish they didn't. There are people who have social anxiety and don't care that they have social anxiety and don't wish that they were not so shy. So having high social anxiety doesn't actually guarantee that you'll endorse this item and say that you wish you were not so shy. It's not as clearly and simply related to social anxiety as it might seem. What else? In a group of people, I would not be embarrassed to be called upon to start a discussion or give an opinion about something I know well. Okay. Not be embarrassed. So this is, again, a reversed item. Because if you're not embarrassed by this, then it's like you don't have, if you say yes to this, that's not socially anxious, right? So you got to think about it as not. So even down here, people with low social anxiety, very low likelihood of having an issue with this. As you go up, this is not a very good discriminating item, right? The difficulty is somewhere, fairly high. That if you get to this point, you're going to start to endorse the item in the direction of social anxiety. And again, you never quite get to 100%. Even people who are super high on social anxiety are not necessarily endorsing this item. By endorsing, I mean saying no to this. Okay? Let's keep going. I am likely not to speak to people until they speak to me. So this item looks pretty good. I mean, it's not, again, not crazy discriminating, but look, I mean, it's hitting people right in the middle of sort of the social anxiety continuum, right? So it's hitting people right in the center. It's you got the low group is fairly low probability. The high group's got a fairly high probability. So it looks like a fairly decent item. It could be more discriminating. It's not perfectly related to social anxiety, but it's got some merit. All right, so it's not as discriminating, say, as this item, but so far this actually is like the prettiest item in terms of monotonicity, in terms of it's the difficulty is fairly, right in the center somewhere here. The discrimination looks pretty good, but it's still not a horrible item. All right, so look at this one. In school, I found it very hard to talk in front of the class. So there are people that have no problem with social interactions. These are people that love going to parties. They hang out with people, talk to people all the time. Very sociable, very outgoing, very extroverted, and still hate to talk in front of a class, right? Like the idea of going up and speaking or whatever in front of a classroom is terrifying, and it may be for reasons that are related to social anxiety, but there's also some reasons that aren't, because people who aren't socially anxious still hate speaking in front of class. Like I don't think I have social anxiety, but I don't like crowds of people. I don't necessarily like being around a lot of people. I'm not a super extroverted person most of the time, but yet my job is to get up in front of people and speak for a living. So I see those things as being very different when having to sort of lecture or speak in front of people. That terrifies most people, public speaking. And it's a separate but maybe related thing to social anxiety, which is why you see that even people who are super low on social anxiety still have nearly a 30% chance, or that 30% of them are endorsing this item because they didn't like speaking in front of the class, even when they have no other indicators of social anxiety. Yeah, so it definitely has moved the difficulty over, right? You need to be higher to endorse this. And it seems like it sort of has a slow movement. It takes a while to sort of get going, but then once you get to a certain point, it starts to take off a little bit. but it's not super discriminating, and it actually is on the more difficult side. I seem to make friends about as quickly as others do. So if you're low, again, so this is, again, a reversed item. Saying yes to this means you don't have social anxiety. Saying no to it does. So you gotta sort of think about that the other way. So if I was to say people who are low on social anxiety are more likely to say yes to this, like not endorse it in terms of in the direction of social anxiety. And as you go up in social anxiety, it's going up, so it's monotonic. It's just not super discriminating, and it's a little bit difficult. How about here? Right, so it actually is pretty discriminating, right? But its discrimination is occurring for higher levels of social anxiety. This question can be used to separate out people who are really high from people who are just a little bit high on social anxiety. Does that make sense? Which is why it's important, and the reason why that is because this item is more difficult. I got to be up here, like almost to the highest group possible before I get 50% chance of endorsing this item. So it's a really difficult item, right? Because even people who are who have some levels of social anxiety may not endorse this item and say, I dislike having people around me. Usually they like having people around them, but just a few of them and people they know really well. So to want to be completely socially isolated is not necessarily typical unless you're at an extreme version or extreme form of social anxiety. So you got to be really high on social anxiety to be able to have a high chance of endorsing this. But when you do, it actually does do a good job of telling these people from these people. Make sense? I can actually discriminate from this group to this group using this item, where the other items I can discriminate between like these groups and this group, or you know what I mean? It depends on where the difficulty is where I actually can do a good job of discriminating. This one just happens to be able to discriminate between the two sort of highest groups pretty well. I often I cross the street in order not to meet someone I see. Again, very difficult item. Discrimination is sort of hard to tell because it doesn't really continue very much. But it looks like it might be fairly discriminating again for the really high groups. If you're someone who's very high in social anxiety, this actually may be pretty indicative of your social anxiety. But for lower levels of social anxiety, people that go down to almost none, it doesn't really tell you very much about differentiating between them, but it does for the between the two highest, maybe the three highest groups. It can tell you a lot about differentiating between them. Okay. I like parties and socials. Again, a reversed item. This is actually probably almost like textbook S-shaped curve kind of thing. Okay, starts off near zero, goes up, curves around. It's reverse coded. So if you're low on social anxiety, you got to think about this as like I don't like, or if you said no to parties. So very close to 0% of people down here said no. But as you go up in social anxiety, the percentage of people saying no to this item goes up. It crosses right around here, so somewhere just to the right in the center of the groups, so you can tell the three highest from the three lowest groups. So you can see why it's important to have multiple questions of different difficulty. This question I can tell if you're in one of these three groups versus one of these three groups, but that's really it. I can tell from the three highest from the three lowest. I need a question like this, like these two, to really tell me the difference between the really high and the medium high, right? I need to be able to separate these groups out and tell differences between them. I need more difficult items that are still discriminating like this. All right, I have no dread of going into a room by myself where other people have already gathered and are talking. It's almost like, it looks like a linear function. It's sort of weird that way. So it's very low discrimination, but it is sort of monotonic and sort of moving in that right direction. Another one, whenever possible, I avoid being in a crowd. It's like the definition of social anxiety. And it seems to be a fairly steady thing where it's separating out the sort of three highest from the three lowest. At parties, I'm more likely to sit with myself or just one other person than to join in with the crowd. It's actually it's fairly discriminating. It's a fairly easy item though. It's on the easier side. than the other ones that are in the middle here. So it actually helps discriminate between these sort of lower groups, because there are people that, again, that are low on social anxiety, but still would rather do this at parties than hang out with the crowd. Okay. I love to go to dances. Again, this is a reverse item. So even people who are super low on social anxiety have a roughly 25% chance of saying, no, I don't. Right, so you can be people who are super extroverted, love, people, love being social, don't want to dance. 25% of them. Right? And then I wonder if they could. We didn't even look at this. So I wonder what the difference would be for men and women. There's probably a difference there too in terms of what the percentage of I love going to dances would look like between male and female respondents. But I think just everybody together. It crosses the 50% line somewhere over here, so it's fairly easy, but not super discriminating. It's just sort of a slow discrimination across there. I'm never happy that when I'm alone. Remember, this I think was one of the most difficult items. You can see why. I mean, you have to be in the highest group to just barely pass a 50% chance of sort of endorsing. All right, so it's super high. At this point, it becomes rather discriminating. You can, discriminate against people in these two groups. It's just super difficult. Right, so that's probably one of the more difficult items. I enjoy social gatherings just to be with people. All right, it's a reverse item, but you get the idea. Let's try to go through this kind of quick. I enjoy the excitement of a crowd. Another reverse item. I do not mind meeting strangers. But only if they have candy or something. I don't know. I have candy at some point. It's another reverse item, because if you don't mind meeting strangers, that's probably not social anxiety. You want to, that if, again, the endorsement would be saying no. When you're low, very few people say no to this as it goes up. This is a more difficult item. Does a pretty good job of differentiating between these two groups, right? It's not crazy discriminating, but it's doing a fairly good job. It looks like a fairly standard, nice textbooky item. So my worries seem to disappear when I get into a crowd of lively friends. Again, I always wonder who the hell wrote this stuff, but again, so saying no would be endorsing it towards social anxiety. So even people low in social anxiety, it's a fairly crappy discriminating item. It's just sort of a flat, almost straight line, very slow increase. Doesn't really tell you a lot about discriminating against people. You have to go, quite a ways away before you can tell the difference between people of different levels of social anxiety. Some people think it's hard to get to know me. That's a weird one. It's social anxiety. It's not very discriminating, because there may be lots of other reasons why that is. Not because you're socially anxious, but maybe you're just, complex or something. I don't know. Maybe you're an a-hole. So people don't get to know you very well. So it may not necessarily be about social anxiety. So this is not actually that well related. It's just sort of cycling upwards. I thought I had one, because I spend most of my time by myself. Well, maybe you do, but not by choice. So that's why it's again, not super discriminating when it comes to social anxiety. Maybe you have a job where you're sort of alone all the time. That's why you do, or something like that. So it may not be by choice. Anyway, so those just looking at some of the stuff across the different items and looking at it sort of graphically. You got factor analysis, which we're going to talk about next. I'm not going to spend a lot of time right now. It's the next topic. The weird part about factor analysis is these are sort of other ways of evaluating items. The weird thing about factor analysis is that it focuses solely on item discrimination. And the basic sort of approach to factor analysis, we don't really look at item difficulty at all. You have to go to something, a version of factor analysis that includes the item means, something like a mean structure analysis, before you get back into looking at the item difficulties. So the focus is solely on that. In this class, in other times when I've taught this course, I've actually covered item response theory to some degree as like an introduction. And it's a nice way of thinking about how to look at item discriminations and difficulties. It looks at all this stuff together. It's a very cool, modern, but very complex way of looking at items and tests and deciding which items work and which don't. It's a very cool process. If testing and psychometrics like this is something you're interested in, you definitely want to look into sort of item response theory and taking more advanced courses that way, because that's sort of the new modern way for psychometrics. So even though classical test theory is still used, usually it's used as a first pass to then move on to then applying something like either factor analysis, which really applies best for continuous items. So if you have like Likert items with 7 choices, that kind of stuff, or item response theory works better for sort of ordinal or dichotomous items. So viewing item response curves at different levels of difficulty, you can sort of, do the same thing we did here, looking at these curves and stuff, but it does it based on sort of like numerical integration, but it actually uses these things called quadrature nodes to then plot everything out. Usually there's like 18 of them or something like that, or 13 of them. I forget. There's some, I think it's an odd number. And they plot out the point at each one of those nodes. And you're able to look at a much more finely tuned version of these item characteristic curves. Anyway, it's more flexible looking at standard error, and then in different ranges of the scale, the standard error can be smaller or larger depending on how good a job or how much information the item is providing. But again, it's a topic we're not going to cover. But I just want to plant the idea in your brain that item response theory, often it's called IRT, is sort of the way that the field is sort of moving towards more and more, especially when it comes to categorical, ordinal, or dichotomous items. Item response theory is more or less the way to go. The last sort of part of this, we talked about criterion reference tests, like a test like on PsychTesting or social psychology or whatever. You're trying to look at a specific criteria, like how much people know that material. Instead of comparing a test to a score on a test or scale to other respondent scores, we can have some specific cutoff that we're interested in, and that people should score in order to pass. It requires that there's a set objective in order to assess whether the objective has been met. So in intro stats, students should learn how to run an independent sample t-test. A criterion reference test could be used to test this. This needs to be demonstrated before moving on to another objective. So that's the key right there, is that you need to demonstrate your knowledge of how to do a t-test before you move on to another topic. So this relates more to this idea of sort of mastery learning, that if you try to do a t-test and you get it wrong, well, then you do it again. And you do it again until you get it correct. That kind of setup for where you're given certain objectives to meet before you move on creates a different kind of scale. So to evaluate these sort of criterion reference tests, you give the test to 2 groups, one exposed to the material and one that has not seen the material. All right, so one's got it, one you taught, one didn't teach it. You distribute the scores for the test in a frequency polygon, and then you look for something called the anti-mode. It's the least frequent value, represents the cut score between those who were exposed to material and those who weren't. Scores above the cut score are assumed to have mastered the material, and vice versa. Like, what does that mean? So this is what it looks like. So you have the anti-mode and the values above and below. So you have someone who answered none of the questions correct. All right, we have nobody in that category. Here are the people that got 1 answer correct. Out of eight questions, they got 80% of people in this group. There's 80 people, the frequency, 80 people who answered only 1 item correct. Then you got another 55 people who answered 2 questions, another 40 that answered 3 questions, and you get to this point where answering 4 questions, which is roughly half the test correct, you get only 15% of people answered that correctly. But as you go up to 5 items correct, all of a sudden it goes back up again. 40 people were able to answer 5 items correct, and it goes up to 6 items. Is that 50 people? 7 items was 65, and then one to get all 8 items, there was like another 100 people or whatever that actually were able to do that. So what does this tell you? Where down here, these are people that are sort of just guessing at material, right? They weren't really exposed to it. Getting down to here, here's the lowest, this frequency are people that actually didn't know the material and were able to get at least 4 questions correct. But in order to get 5, 6, 7, 8 questions, you actually have to start mastering the material. So you can actually start to tell who has mastered material and actually worked on sort of learning the material from those who are just guessing or able to work out, a couple problems. And by looking at this anti-mode, the reverse sort of mode. So this tells you these people mastered the material, these people did not. You can then go forward and apply that in order for a student to show that they mastered the material, then they take a quiz, they got to get 5 or more questions correct to show that they've mastered it. And actually be able to then use that as a criterion reference test. This tells you what your criterion is. In order to show mastery, you got to be able to do 5 or better by looking at this frequency polygon for criterion reference test. Because of that, it's often used with this sort of mastery style learning, where I had a friend of mine did their graduate thesis years ago on mastery learning. This idea of having students continue, to learn material and take an exam or a quiz or something until they actually get it correct. Once a student indicates they've mastered the material, he or she moves on to the next module material. If they do not pass the cut score for mastery, then they receive more instruction until they can master the material. How do we know what the cut score is? Based on doing it this way, we figure out that the cut score has got to be 5 or better for them to show they mastered the material. So they take a quiz, they get a 5 or better, they mastered it, they go on to the next material. They get less than a 5, they go back and do some more learning, they take another test, you get the idea.